Density is a measure of how much mass is packed into a given volume. The formula for density is density rho equals mass kilogram volume cubic meter. Density is important in determining material properties. For example, water has a density of 1,000 kilograms per cubic meter. If a material's density is higher, it will sink in water. If it's lower, it will float. Relative density compares the density of a substance to that of water. Since water has a density of 1,000 kilograms per cubic meter, the relative density formula is relative density equals substance density, water density. Now let's calculate the density of an object with mass 445 grams and volume 50 cubic centimeters. Force is a push or pull that can change an object's motion or shape. The formula for force is force F equals mass kilogram times acceleration meter per second squared. If we apply force to a stationary object, it can start moving. If an object is already moving, force can change its speed or direction. For example, imagine kicking a football. It moves because of the force applied. Next, we'll discuss weight and how it differs from mass. Unlike mass, which remains constant, weight is the gravitational force acting on an object. The formula for weight is weight W equals mass kilogram times gravitational acceleration. 9.81 meters per second squared, since Earth's gravity is 9.81 meters per second squared. An object with 10 kilograms mass has a weight of W equals 10 times 9.81 equals 98.1 N. This means weight depends on gravity on the moon. Objects weigh much less due to weaker gravity. Next, let's move on to pressure. Pressure is the force applied per unit area. The formula for pressure is pressure P equals force N, area square meter, for example. A chair with 4 legs has a different pressure on the floor compared to a needle pressing into a surface. The smaller the area, the higher the pressure. Now, let's calculate the pressure exerted by a desk leg with 50 in 4s and a cross-sectional area of 4 square centimeters. Work is the energy transferred when a force moves an object. The formula for work is work W equals force N times displacement M. Example, if you lift a box with 100 N force over 2 meters, the work done is W equals 100 times 2 equals 200 J joules. Now, power is how fast work is done. The formula for power is power P equals work J times S, for example. A crane lifting 1 ton of concrete does 98 kilojoules of work in 2 minutes. To find power, P equals 98,000 J divided by 120 S equals 816.67 W. The ET concludes our lesson on physical quantities and units. Let's summarize. To recap, we explored unit conversion methods, density and relative density, force and weight differences, pressure, and its effects, work and power calculations. Thank you.